Hello. Today we're ready to start a new unit in Algebra 2. So we're going to be looking at systems of equations. This is an idea you've talked about before in Algebra 1. You had different ways to solve systems of equations, and we'll talk about those same ways again this year. But we will be expanding on that skill as time goes on. So today will feel familiar to you because we're going to talk about how you can solve systems of equations by graphing and by substitution. So when I say system of equations, I'm talking about having two equations or more equations. But today we're going to start with just two equations because we're going to build on what you know from Algebra 1. So if you look at my example here, we are going to look at the system of equations y equals 3x plus 1 and negative 4x plus 2y equals negative 2. So it's a system because it's got two equations to it. And we are going to first look at this by graphing. So what we're looking for is there an xy pair, or a point, in other words, that would satisfy both of these equations, that would fit the red equation and also fit the blue equation. So I have them graphed over here on Desmos. So let me pull this up real quick. So the red equation is the y equals 3x plus 1. So you'll see that with the red line. The blue equation is negative 4x plus 2y equals negative 2. So here's the red line and here's the blue line. And so the system is, I'm looking for, is there a point that's on the red line and the blue line at the same time? If you want to think about art, remember how red and blue make purple? You would be looking for, if these were paints, where would my point turn purple? So they don't turn purple on Desmos, but move this around a little bit. Do you see that the two lines are intersecting right here? That point, negative 2, negative 5, is on the red line, so it's a solution to the red equation. It's also on the blue line, so it's a solution to the blue equation. So you're looking for where the two lines intersect, because that would be the point that is on both of those lines. So when you have lines, which we're going to start out with what's familiar from Algebra 1, which is linear systems, you might get two lines that cross. So you might have an intersection point like this. If you have two lines, do they have to cross? Is that a thing that has to happen? They could run parallel. Okay, so if you are looking for where two lines are going to intersect and they run parallel to each other, are you going to have any luck? Nope, they're never going to cross. That means, like, if this was red and this was blue, there would be no purple point. So there's a possibility of getting no solution to these. The third way these two lines could interact, besides crossing somewhere or running parallel, is I might graph one and the other one might be the exact same line, in which case if this yardstick was red and this one was blue, the entire thing would turn purple. So that would be infinitely many solutions. So that's also a possibility that we'll see as time goes on. So that's a review from Algebra 1, you know that stuff. So anyway, the x value here in my solution would be the negative 2, and the y value would be the negative 5. So I know what this comes out to. I know from my graph that's what I will get. So we can graph these. So let's put some more notes down here. So these are your notes, so go ahead and get out paper in your notebook and start writing these things down. We can graph these to find the point for x, y pair that is on both lines. This point is a solution to the system. So this point is a solution to the system because it fits both equations. So what was that point again? It was negative 2, negative 5, right? So let me write on this for a minute. if I take the -2 and plug it into the red equation, 3 times -2 is -6. Add 1 to that, you get a 5 for that y value. So it fits in the red equation. It's a solution to the red equation. Now let me put the -2, and it was -5, right? -5 in for the x and y to verify that that's a solution to the blue equation. So when I take -4 times -2, that would be a +8. When I take the 2 times the -5 from the 2y part, that would be a -10. And 8 plus -10, or 8 minus 10, whichever way you want to look at it, does that actually come out to your -2? Yes, it does. So it's a solution to the blue equation too. So that's how I can verify that that is actually the solution to the system, because it satisfies both of those equations. So, and we got that by graphing. Now, there are definitely pros and cons to graphing. So, can you think of any things that are nice about having the graph? So, what was helpful about that? Well, one thing is that it's visual. So this, we'll put pros here. No, I'll say we like graphing. We like graphing because, oops, that's not how you spell. Because it is visual. We can see our solutions. So that's really a benefit of it. Like, you can point to it, like, there it is. We can see our solutions. Can you think of any reasons why you might not like graphing? Because I know a lot of you, when I say we're going to graph, are like, ooh, so why do you do that? So we don't like graphing. We don't always like graphing. How about that? Because, let's face it, sometimes it's annoying to have to graph. If I didn't pull it up on Desmos and you had to graph it by hand, that would have taken a lot longer, right? Okay, so sometimes, I will admit it, graphing can be annoying. Like I'm thinking when you have to graph by hand. Oops, that's where I wanted it to go. And, okay, this didn't come up on my Desmos one here. These two lines intersected at nice whole number or integer solutions there. That is nice numbers. That doesn't have to be the case. If two lines cross, they might not cross at nice integer solutions. And if they're not crossing at nice like integers, it's a little bit more of a pain to read the graph. So let's put that in here. Sometimes, oops. Sometimes with a, oh my goodness. Sometimes with a graph, it can be hard to find exact solutions. So, we're not going to spend any more time on graphing right now because A, I don't think it's your number one choice most of the time if you have to choose a way to do it. B, that's in an Algebra 1 standard. That's not an Algebra 2 standard to solve these by graphing. I just wanted to get your prior knowledge activated so you would remember what the picture looks like because it's powerful to see the picture. But we are going to talk about how to solve these by substitution next. So let me get a new page here. So we're going to use the exact same system. So we already know what the answer is going to come out to. So let's say we're going to solve by substitution. Solving by substitution. So what's it mean if you're going to substitute something? Like, I have a substitute teacher sometimes. What does that mean? That means I go out and somebody else stands in my place, right? You replace me with with somebody else. That's what you do when you substitute. And when you substitute in math, it has to be equal values. So like, if I want to make a trade, it has to be fair. Think about money. If you want to exchange money, like if you have a 10, is it fair for me to give you 2 5s? Yeah, it looks different, but that's equal. That's fine. You can do that. We can make that trade. If you have a $10 bill and you want to trade it to me for 5 and 5 1s, is that fair? Is that good? Is that a good trade? Yeah, that's an equal trade. So we can make that substitution. So it has to be equal in value. It might look different to have a $10 bill or a 5 and 5 1s, but it's equal in value. So that's important in this. We have to trade equal values here. So I'm going to switch to writing now. So my first equation, if you remember, I'm going to color code stuff today. I find that helpful, so you might want to do that as well. But my first equation was y equals 3x plus 1. And my second equation was negative 4x plus 2y equals negative 2. So that was my system of equations, my two equations. And if I look at my red equation, it says that y is equal to what? 3x plus 1? Yeah, so that means y is equal to 3x plus 1. So I have this little paddle here, two sides of it. Y is equal to 3x plus 1. So that's where I'm going to get my trade. I can make a trade for a y and replace it with a 3x plus 1 because those two things are equal to each other. Okay, they're equal in value. It's like two sides of the same coin. If I show you a quarter heads versus tails, it looks different, but it's still worth the same amount. That's what's going on here with this red equation. So here's what I'm going to do. I'm going to put this in a box so you can think about it looking like my little paddle here. So y equals 3x plus 1. So every place I see a y, what can I replace it with? 3x plus 1. So what we're going to do is we're going to take that thought over to my other equation. Oh, you probably can't see that thing. So let me rewrite that real quick. Down a little bit. Let's put it here. It was negative 4x plus 2y equals negative 2. Sorry about that. I forgot where my picture was on this. So back to the thought of replacement, substitution. A y is equal to a 3x plus 1. So right here, I see a y. That's where I'm going to make the trade. That's where I'm going to replace it with 3x plus 1. So the blue equation, I'm going to copy it down just like it appears until I get to the part where the trade is going to happen. So boom. This is where my y is going to get traded for the 3x plus 1. So this is the substitution step. And since I have this entire quantity, 3x plus 1, going in place of the y, I need to put that in parentheses because that entire quantity is going to get multiplied by the 2. So let me copy down the rest of my blue equation there. Equals negative 2. So you can see the substitution step that has happened. So now we want to simplify stuff. So I have a 2 that needs distributed. So right here, I'm going to pass out that 2. So I'll have negative 4x plus, oh shoot, that'll be a 6 now. 6x. And then the 2 times the 1 is 2, so plus 2. And then I'm to my equal sign, so I'll bring down my equals and bring down my negative 2. Okay, so that's where we're at right now. So let's do a little bit more simplifying. You see these like terms right here? Well, let's go ahead and add those together. What's negative 4x's plus 6x's? That'd be 2x's. So we have 2x plus 2 equals negative 2. And we need to get rid of the plus 2, so we'll subtract 2 on both sides. So this part should feel real familiar to you. Those go away. So I have 2x equals negative 4. So if I divide both sides by 2, that means x equals -2. So that's part of my solution. I want you to remember what we're going for here is if I pull up my graph again, remember we said that the solution to the system was that point, and a point is an ordered pair. It's an x and y together. So I am like halfway there right now because I have my x coordinate. It's -2. So I need to figure out what the y value is. Okay, so x is -2. So we're going to keep that in mind. Let me scroll up a little bit so I can see my original, oh, come on. So I can see my original system. Maybe I can scroll. There we go. So I'm looking at the red line right now where it says y equals 3x plus 2. Whoa. Y equals 3x plus 1. And what was x again? What did we just find x equals? X equals -2. Okay, so we're going to be able to substitute again here because we know that x is actually equal to -2. So I'm going to take this line right here and I'm going to, well, you can't see it there, can you? So let me write it down here a little bit farther. Y equals 3x plus 1. And I'm going to fill in this x with my -2 because I know that x is equal to -2. So y will equal 3 times -2. See, there's that substitution step again, plus 1. So 3 times -2 is -6. Add 1 to that, you get a -5. So y equals -5. So if I scroll back down to where I was starting to write my ordered pair here, -5 is my y value that goes with my x value of -2, which we already knew that's what it was going to come out to. So that verifies that we did everything correct there. We found our solution to the system by substitution. So now, when is this helpful? So let's do some pros and cons for substitution here. So substitution, pros. This is really good if you already have one variable by itself. So really good if you have one variable, one variable already by itself. In this case that we did, we had the red equation said y equals whatever. So the y was already by itself. That is like saying, please use substitution to solve this, okay? If you have that, it's like perfect setup for substitution. It's really good if you have one variable already by itself. It's pretty good if there is a variable with a coefficient of 1. So what I mean by that is if we had, let's say we had an equation where it said x plus 2y equals 5. So that's, say that was one equation in a system. I don't have a variable already by itself, but what's that x coefficient? It would just be 1, right? In front of the x, understood 1 there. That x would be pretty easy to get by itself. I know that x isn't by itself yet because there's that plus 2y in the way, but I'm pretty sure you could make that plus 2y go away real easy. How would you get rid of the plus 2y? Yeah, you would subtract 2y on both sides. So that is not a difficult step. So you would say that x equals 5 minus 2y, or you could say negative 2y plus 5 if you preferred. But that wasn't a terrible step. And then that puts you in the really good category because then you have one variable that's already by itself. So it's pretty good if that happens. It's not great So let me get my writing back up here. So not great at all if every variable has a coefficient not equal to 1. So sometimes you'll have a system, maybe you'll have a system like, oops, let me write. 3x plus 5y equals 7, something like that, and 4x minus 3y equals 11. And I'm not saying you couldn't solve this by substitution, but it would not be my first choice, because if you look at the first x, the first y, the second x, the second y, all of them have coefficients in front of them. And the thing that makes that a drawback is you're going to have to divide to get one of those letters by itself, which means you're going to have fractions everywhere, which is fine, but not usually our first choice in life. So we'll have another method tomorrow that we'll review, which you've already talked about in Algebra 1, to deal with something like that. So one thing that you want to think about in algebra is, yes, I have different tools. Which tool is the most appropriate in this circumstance? So those are the two cases. If you got a variable already by itself, or if you have a variable with a coefficient of 1, those are the two cases where I would be like, oh yes, I'm using substitution here. So, well, I think that is everything I want to show you example-wise. So we'll do some problems with solving by substitution, solving the system by substitution. So remember that Jesus loves you, and so do I, so do your math.